I had to write it on the board. It didn't print correctly. The equations show up when you look at it on Canvas. But
This is
this is one of the free response questions. So this is for that assignment that you'll turn in. Free response assignment. It had 2 questions on it.
This one, number 2. This is number 3. This is number 2.
So this problem is really awful, but we can use that trick I showed you yesterday. Rishi, I don't know if I showed y'all this.
Yeah, no, the pyramid.
Did I?
Yeah, you did. Rishi, why are you saying yes?
I was saying I don't know if I showed Rushi.
Yeah. Oh, legit? I thought you said y'all. I heard y'all.
I did, but
Just not us y'all.
yeah, the other y'all.
Oh, okay, the other y'all.
Alright. So, whenever I've got to expand x plus h to the 4th, I can use Pascal's triangle here so that I don't have to write out x plus h 4 times. I may have done that on the solutions. I can't remember because I wasn't sure if I was going to. I think I actually multiplied it out on the solutions just because I wasn't sure if I was going to teach you Pascal's triangle here. But you don't have to. You can use Pascal's triangle. That's fine. So, one of the more challenging parts of this is fitting it all on one line of the paper. So you're going to have x to the 4th power. What comes next? Yeah, 4th power, not 5th. So we're going to use this line, 4, 6, 6, 4, 1. X to the 3rd, h. 6. Okay.
How do y'all know the x and h?
So you just start, the x is first, so it's x to the 4th, 3rd, 2nd, 1st, no x at all. And then with the h's, you'll have no h's, 1 h, 2 h's, 3 h's, 4 h's. I will be checking for the notation. It is hard to fit all of this on one line. Minus, we're going to have 3 times x squared plus 2xh plus h squared plus 2. And then I'm going to distribute that negative there, minus x to the 4th plus 3x squared minus 2. So this part right here was my f of x plus h. This part was my f of x. Alright, so this right here that I have right here, there's my f of x. This was equal to all of this stuff right here. This, I'm running out of colors. This part right here is this stuff. Is this stuff right here, and then it's really easy to lose it. But this 2 right here is that 2 right there. This one's a really good one to memorize the answer on, so that you can make sure you get that answer.
By the answer, do you mean?
Like the answer when we get to the final. Okay. Because all of this is hard to memorize, but if you memorize the answer for this, you can. If you don't get that answer, you can kind of go back up and figure out maybe where you messed up, or you could just go pretend like you actually got that answer, and I may or may not see it there. I mean, your work's going to have to look pretty right, and I may just not realize that you forgot to have a negative here or there, but yeah. So, is it okay with you guys right here? I really don't know. If well, alright. We got this 3 right here that's got to be distributed. I'm just going to write it. It's okay with me if you like erase it and distribute there so you don't have to write all this again.
Wait, so I'm not gonna erase it.
I was wanting to erase this right here and just replace it so I didn't have to write all this again, but I just thought I would. 3x squared minus 6xh minus 3h squared plus 2 minus x to the 4th. Alright, so you got all of this stuff, and when we're doing a problem like this, everything that does not have an h should cancel out. So if it doesn't, you messed up somewhere. So the x to the 4th and the negative x to the 4th cancels. All of these things have h's. I've got a negative x, 3x to the 3rd, 3x squared, and a positive 3x squared. And then I've got a positive 2 and a negative 2. And so if you look at all the terms you have left, you should have h's with all of them. So you can factor one h out. Alright, we're okay here. Okay, now h's cancel. You are going to plug in a 0 for all of the h's. So you'll have 4x to the 3rd. You can drop limit notation here, Daniel. Not that you had any on your paper to drop in the first place. But you can drop limit notation here because you're plugging a number in. Just the h, yeah, not the x's. And so pretty much, you don't have to. I am to be extra clear on what's happening here, but if you just want to say, oh, when that h turns to a 0, I'm just going to get 4x to the 3rd minus 6x. That's fine. So if you skip writing this step right here, that's fine with me. Because pretty much any term that has an h left with it is just going to disappear. And so let's call this f prime of x, because that is our derivative. You've had it for like 8 minutes and 45 seconds now.
No, dude, this is the long question. Like, Jack does it. Jack dude, no, like literally, I did it in like one line. It's not even like subjective.
You can see the shortcut, right?
Yeah, it makes so much sense.
Yeah. Yeah.
I think
yeah.
I get the trick.
Yeah.
I can see a pattern, but I understand the trick now.
Yeah.
I don't trust it. No, I understand it. I don't know how to do it.
You know, see the trick? Yeah. So, if you're seeing the trick already, that is good. You still have to show limit notation on this, for right now. But whenever, like, moving forward after we have finished this section, then you'll get to use the trick. The trick, knowing the trick that I'm not going to teach you yet, also is good for checking your work to make sure you did it right. Because the trick is much more reliable than than all of this right here because it's really easy to make a mistake.
I'm gonna just figure it out right quick.
Okay. All right. So that's part A. Part B. Let's see. Oh, that letter of recommendation reminds me though. If any of y'all need a letter of recommendation from me, I'm thinking October 15th when most of those are due. Please let me know that really soon, because if you let me know the last couple of days, I'm not going to have time to do it. So if anybody needs one from me, you just send me an email, let me know that you need, or ask me after class or something. But I'd be happy to write one for anybody in here. But I just need a little time to get those written. Yes, I will write any. And I never put anything bad in a recommendation, except for sometimes some, like Common App doesn't do this, but like some of the ones will like ask you to tell areas in which the student needs to improve. So you pretty much have to say something, an area of weakness, but I usually try to make, I don't say like, Ethan cannot get along with others and is generally a rude person no one wants to be around. I don't say super mean things, just things that make it work. I would say student refuses to write limit notation, and and his homework looks like someone who is insane has done it. Yesterday it was sideways, Daniel. You had problems just sideways. Perpendicular to the notebook paper lines. I shouldn't even let him know that it bothers me because I think it's going to make him do it more. But if you do need a recommendation, let me know, because I know that first deadline is October 15th, and that's coming up soon. So I will only put nice things. If I feel like I don't have anything nice to say, I would tell you that I wouldn't do it, but I would do one for any of you guys. And I never put anything mean. Some letters are shorter than others, but I've never put anything mean in one. So.
I would have a long letter. Are you sure this determination?
I have nice things to say about.
Mrs. Strana told us that for one of the letters of recommendation, she put this student is a shooting.
I remember her talking about. I taught the student. I'm pretty sure that I know about that one.
Yeah, it was ridiculous.
I'm pretty sure he's the only one that, she's the only one he could even get to agree to write anything on paper about him.
Oh, man.
I don't know if he did or not, actually. I can't remember. It's been a long time ago, if it's the one I'm thinking of.
If you go in with that letter of recommendation, that'd be good.
If that's the case, they're really not reading those letters of recommendation. Yeah.
If I was in admissions and I
can't even remember his name. I can kind of picture him. If it's the one I think it was. I want to say it was like one of my first or second years teaching here, so it was like 2010 or something. You were in the hallway throwing tennis balls down the hall after school every day whenever your mom was across from me. That's what you were doing whenever this kid was here.
Oh, that was up at the wood park.
Yeah. Yeah, it was.
A little bit.
I think it was maybe like 2 years that I was up there, and you'd take a tennis ball out in the hall, and you'd throw it up and down the hall, and sometimes it would bounce into my room, and you'd run in and get it, and you'd run back out. Yeah. We saw grown up. All right. So, part B. We're not getting much done here. We need to get some more done. Okay. So for part B, all right, this is tangent line at 1. So once you've done the hard stuff for part A, tangent line at 1, you need a point. How do we find the point?
With the point given by the slope.
For the point, we just plug 1 into the original function. So 1 to the 4th minus 3 times 1 squared plus 2. So we're just plugging in here, which is going to give us 1 minus 3 plus 2. So we get 0. That means that our point is at 1, 0. So that's our point of tangency here. So for the point, you're just plugging into the original. And for our slope that we need, what are we going to do for the slope?
Slope, y equals m.
We're going to do that in a minute, but first we have to have a number to put in for the m, which is the derivative. So f prime of 1. Plug 1 into your derivative, and that is going to give you the slope at that point. So we have 4 times 1 cubed minus 6 times 1, which is going to be 4 minus 6. So we'll get negative 2. Okay, so our point is 1, 0. Our slope is negative 2. And now we will use that formula I gave you guys yesterday. So it's going to be y equals negative 2 times x minus 1 plus 0. You don't have to write the 0. If you do write the 0, it's fine. You don't have to. Don't simplify that. Like, it's fine if you don't want to write that 0, but don't simplify it. Don't even distribute the negative 2. I know it's super easy to do. If you do it correctly, I'm not going to count off for it. But what if you forget to do negative times negative makes a positive, and then you get negative 2x minus 2, and then you've missed the problem because you didn't just leave it. So just leave it on those.
The equation is y equals mx minus x plus y.
Yeah, it's an x1 and a y1 right here. So those are where you put the points in. Yeah. Okay? All right here. All right, so C. C is not so bad once you realize what it's asking.
Is it big or is it small?
It's not going to have a lot of room for, you don't have to have a lot of room for the word.
Yeah.
Probably so. Okay, so for C, we are supposed to find the x-coordinate of each point at which the line tangent to the graph of f is parallel to the line y equals 9. So, we want to know where the tangent line don't do anything with the 9. So, I'm going to graph it on, you can't graph it on Desmos obviously here. This is very much not a calculator active problem. But for you to picture what we're talking about here, I think is helpful. So the function is x to the 4th minus 3x squared plus 2. So it looks like this. And the line y equals 9 is up here. We want to know where we've got tangent lines that are parallel to this line. So what do we know about this line? What can we say about it? Slope is 0. So the slope of this line is 0. What do we know about the slope of parallel lines? They're the same. Yes. So, the slope of our tangent lines are going to have to be 0 also. It's going to happen right here and right here at these minimum points right here. But you're not going to have a graph, so you're not going to know that. But I do know my derivative is f prime of x equals 4x to the third minus 6x. And that derivative, what does the derivative give me? The slope at any point. I want the slope at these points to equal 0. So I'm going to set 4x to the third minus 6x equal to 0. How do I solve that? Factor out of x. You can take a 2x if you want, or just an x. It doesn't matter. If I take a 2x, I'm going to get 2x squared minus 3 here. Right. Then, what do? Right. We'll have 2x equals 0, which is just going to give us x equals 0. And then over here, we'll say 2x squared minus 3 equals 0, which is 2x squared equals 3. Divide by 2. X squared is 3/2. And square root both sides. X equals plus or minus square root of 3/2. Don't simplify that either. You can rationalize the denominator on that, but don't. You can leave it like this. I don't know, he's talking about you, but I couldn't hear what he said. All right. Questions?